Our next presenter is James Mills. James is Ceva's diagnostic project leader. His presentation today is going to be titled Salmonella, Observations of a Targeted GPS Approach. Please join me in welcoming James Mills.
Hello, I hope you all can see this. Thank you, Gary. Welcome to my presentation today on Salmonella, observations of a targeted GPS approach. My name is James Mills. I'm in charge of the bacteriology, parasitology, and serology laboratory within the Scientific Support and Investigation Unit of Ceva Animal Health. And I thank you all for your attendance today in this year's Ceva Live virtual meeting. I'd like to start with a little overview on the impact Salmonella makes. Salmonellosis is the leading cause of foodborne illness next to norovirus. This causes over 1 million illnesses annually and is the leading cause of hospitalizations with over 19,000 and over 300 deaths annually. Economic losses are in excess of $3.7 billion, and that's an annual figure. In the U.S., Salmonella pylori and Salmonella gallinarum serotypes are both pathogenic to chickens, but have been significantly reduced, and therefore our shift has been to one of food protection and reduction or elimination of clinically relevant human serotypes. This table here is from FoodNet and shows the incidence of the top 6 foodborne serotypes from 2019 compared to the prior years. I want you to note right here that Salmonella infantis is on the move. In 2020, our laboratory received 65 cases for Salmonella survey purposes, and we performed 466 tests consisting of breeder and broiler sources from multiple companies. And these were for the purpose of surveillance of serotype prevalence, isolate characterization through GPS, which is genotyping, phenotyping surveys, for autogenous isolate selection and vaccine production. Our goal is a targeted approach focusing on reducing the prevalence of human outbreak-related serotypes in complexes, especially in processing plants. The data gathered are also useful for investigation and monitoring of bird health, especially with certain strains of Salmonella enteritidis. Our Salmonella surveillance begins with sampling in the field. Now, this can be feed sources, hatchery samples, food swabs from grow-out houses of litter, any environmental swab, or processing plant rinses. Lab tests consist of isolation followed by characterization and potential vaccine production. In the bacteriology lab, we utilize National Poultry Improvement Plan methods for isolating Salmonella. The samples are enriched, and suspect Salmonella isolates are confirmed by intergenic sequence ribotyping, followed by biochemical identification and phenotyping using the API 20E system from bioMérieux. And you can see the strip here on the lower right side. That's just a series of biochemicals for identification. ISR serotyping is performed according to a method developed by Dr. Jean Gard. This method utilizes PCR targeting the 23S ribosomal region and then sequencing a smaller 5S region within that PCR amplicon. The primer sets for amplification and sequencing are shown here in this table in the center of the slide. This method can identify 133 serotypes using 242 unique ISR sequences. And this is not only helpful to confirm the serotype identification, but to serve as a method of genotyping as well, because some serotypes can have multiple ISR sequences. And it's quite common for us to see 2 different ISR sequences for Salmonella Kentucky shown here, and also 3 separate ISR sequences for Salmonella typhimurium. And if you notice, it's quite small, sorry for that, but the very first typhimurium listed here is the monoflagellated typhimurium that is also increasing. So these are the results of surveys from 3 customer companies since 2016. Enteritidis and Kentucky, shown here, are the predominant serotypes. And it's important to note that our GPS process is successful in reduction of those significant human outbreak serotypes. Enteritidis is a tricky serotype, as I think most of us know. It's very closely related to Salmonella pylori and gallinarum, and it is well adapted to colonize a chicken. So as I've said, we have focused approach on autogenous vaccination. The goal is to change the prevalence of serotypes, targeting the reduction or elimination of relevant human serotypes. And I'd like to note the importance of continued surveillance throughout the vaccination program. It doesn't stop and can't stop with the first vaccine. Continued surveys of phenotypes is necessary. And if needed, we can genotype as well. Changes are made in vaccine formulations throughout the surveys based on the findings. And on this slide, I'd like to show you the results of one customer's focused approach over the last 3 years. And to reduce the noise of this chart, we're just looking at the top 5 hatchery serotypes. And based upon the first half of 2017, a selection of isolates for use in autogenous vaccines was suggested and produced around the third quarter of that year. This vaccine contained 2 Salmonella enteritidis, 2 typhimurium isolates, and 1 Salmonella Heidelberg isolate. And with this arrow, I want you to watch the reduction of Salmonella enteritidis. So in the beginning of 2018, the vaccine was changed to contain 3 enteritidis isolates, 1 isolate each of Salmonella typhimurium and Salmonella Heidelberg. And later that year, the vaccine was changed to include an Infantis isolate, which showed up during Q2 surveillance at the hatchery. Note here that Salmonella Heidelberg was not isolated in the hatchery during 2018, and the change in prevalence mid-year was a shift to Salmonella Kentucky as the predominant serotype. And now with that arrow, watch the rise of Salmonella Kentucky. So in 2019, the vaccine formulation didn't change. They were still using the 2018 formulation. And Heidelberg and Infantis have not returned to the hatchery, and Kentucky remains the prevalent serotype. So in the beginning of 2020, Heidelberg had to be removed from the vaccine as that isolate had expired, and there were no new isolations of Heidelberg, so we could not add one to the vaccine formulation. And during this year, Heidelberg and Infantis have still not returned to the hatchery, and Salmonella Kentucky still remains the prevalent serotype. So these surveys have the potential to lead to new and interesting findings as well for further investigation. In this instance, we noticed a rare Salmonella typhimurium phenotype that was atypical of normal typhimurium. We presented this data at this year's Western Poultry Disease Conference. Genotyping these isolates showed that they all lacked a CRP gene, which regulates a number of functions, but importantly, carbohydrate utilization, some antibiotic resistance, and virulence as well. Interestingly, could this genotype be used for autogenous vaccine production with reduced virulence? These charts are quite noisy here, but they do show you the difference in the phenotypes here. I've highlighted some of these in yellow. Those are the atypical phenotypes on the left, the lower left side. And then on the lower right side, you can see kind of a heat map of the gene present, and this line here about in the center of that little chart, it represents the absence of the CRP gene in those atypical phenotypes. So our surveys are valuable in gathering data also to support investigations into significant bird health issues. Salmonella enteritidis is a primary pathogen in chick mortality. And outside of surveys, we've had clinical submissions of sporadic air saculitis, increased mortality, with subsequent isolation of virulent E. coli, enterococci, and Salmonella enteritidis. This research is currently ongoing, and we are sequencing isolates and investigating possible links here. Our GPS program provides a baseline of prevalent serotypes by which we can compare these virulent enteritidis strains and provide solutions that directly impact bird health. So thank you very much for your attention and participation in this year's Ceva Live virtual meeting, and I look forward to answering any questions you may have.